Good morning, and welcome to today's Electronic Design Webcast. Our topic today, using 60 gigahertz radar to enable smart sensing in industrial and automotive applications, sponsored by Texas Instruments. I'm Bill Wong, Senior Technology Editor with Endeavor's Design Engineering Group. To begin, let me explain how you can participate in today's presentation. First of all, if you have any technical difficulties during today's session, simply hit F5 to refresh your webcast console. If you need assistance solving common issues, please click on the yellow help icon below the slides. This webinar interface allows you to resize the presentation by clicking on the maximize icon or by dragging the lower right corner to enlarge the window. Additionally, we welcome your questions during today's event. We will answer as many questions as possible during the Q&A session that will follow the main presentation, but please feel free to send in your questions at any time. To do so, simply type your questions into the question window on the side of your screen and hit the submit button. Also, please be aware that today's session is being recorded and will be available on the Electronic Design website within the next week. You'll be notified by email when the archive is available. Now let's meet today's speaker. Kishore Ramahi is a product manager for millimeter wave radar technology at Texas Instruments, focusing on enabling radar sensing applications for automotive in-cabin market. Since joining TI in 2010, he has held various engineering and product management roles. You can learn more about our speaker by clicking on the blue speaker bio widget on the console toolbar. Now let me turn things over to our presenter. Sure, the floor is yours.
Thank you, William. Hello, everyone. Welcome to our webinar today. I'm going to talk on 60 gigahertz radar sensors from TI. Let's get to the basics first. For some of you who might be new to millimeter wave technology, millimeter wave is really that band of spectrum from 30 gigahertz to 300 gigahertz, and the millimeter wave sensors can typically provide three main information when it detects an object, at what range or distance the object is or a person is, with what velocity or the speed the person or the object is moving towards or away from the sensor, and at what angle it is located. So these three are the main information which a radar sensor can provide, and it can work in any challenging environmental condition, be it extreme sunlight, complete darkness, cold, heat, snow, doesn't matter. Millimeter wave sensor can provide accurate information in all of these conditions. And Texas Instruments is offering a portfolio of sensors both in 60 as well as 77 gigahertz in a single chip form factor solution. And it's also extremely low power because of our RF CMOS technology, and it is highly integrated with memory on-chip processing without the need for additional MCU. And it's also a scalable portfolio across automotive and industrial applications, and you can reuse the software as well. And we are also innovating with offering antenna on package technology, which if you consider, traditionally it has been the antenna on the PCB. And also we are offering imaging radar, which can provide LiDAR-like performance at the lowest cost point. And we are investing both in the automotive as well as industrial applications. Let's get into details on each of the sectors where radar sensors can be used. First, building automation. Here you can see some of the use cases, both outdoor as well as typical indoor applications. The main goal here for building automation is really to automate the sensors, thereby increasing the efficiency of the system. To take an example, for traffic monitoring example, the sensor's goal is really to control the congestion by counting the number of cars in a particular lane or how long it should wait for the red light signal. The other example, for example, in automated gates and doors, today if you see without radar sensor, the door keeps opening even if there is a bird or some object coming in front of the doors. With radar sensors, you can actually determine when exactly to open the door and thereby conserve the AC, for example. And in the indoor space, the goal is really to identify how the occupancy is of the occupants or the people, and also to see if there is a particular pattern in the motion of the people. For example, in elderly care, it would be really worthwhile to determine if the person has fallen and then report the incident accordingly. And privacy is a key concern here. Hence, radar technology, especially 60 gigahertz sensor, shines and is a very good sensor for these applications. The second use case is what we call factory automation use cases. And with the advent of Industry 4.0 protocol, the goal really is to increase the interaction between the humans and the robots or the machines. And you can see it could be used both outdoor as well as indoor applications. One example could be autonomous delivery. Here, the radar sensor could be used to detect obstacles around the sensors, including humans, and help it maneuver from point A to point B, and thereby increasing its own dependence and dependence on the humans lesser. The other application here, similar application, is robotic lawn mowers. And on the indoor applications, if you have seen in the factory automation setups, the robotic arms, for example, could make use of radar sensors to determine if there is any humans around and thereby control its behavior in a safe manner as well. And some of the other applications listed here are cleaning robots, driverless forklifts. 60 gigahertz and including in some cases 77 gigahertz radar sensors are a perfect fit for these applications. The third automotive use case which we are going to discuss here, mainly from the point of 60 gigahertz use case, is in-cabin sensing, which is gaining a lot of traction these days, primarily from the point of view of child presence detection, which has found its place in a Euro NCAP roadmap. Hence, a lot of car manufacturers are going ahead to implement this function. In addition to that, there are also other functions such as seatbelt reminder, occupant monitoring, which a single sensor can provide at the cost of replacing all additional sensors such as weight sensors. It could also be used for counting occupants. A good examples would be detection or counting of children inside a school bus. And radar could also be used for detection of vital sign of a driver and detect this fatigue state. And we are also seeing some gesturing applications for control of HMI or even interior lighting and control. And 60 gigahertz radar is a very good sensor to address these applications. So here I want to introduce our 60 gigahertz as well as 77 gigahertz radar portfolio with more onus on 60 gigahertz sensors. If you notice here, we really have a scalable portfolio of sensors. We call our sensors starting with XWR, standing for WaveSense, and AWR stands for Automotive WaveSense Radar. IWR in our portfolio stands for Industrial WaveSense Radar. And in the 60 gigahertz portfolio, at the very middle, you can see XWR6443 device is our lowest cost sensor today in our portfolio. It has integrated transceivers, comes with 4 receiver, 3 transmitters. It has integrated MCU. It is an R4F processor, 1.4 megabyte memory, and also an inbuilt signal generator with 60 to 64 gigahertz band. And with respect to interfaces, it comes with CAN or CAN-FT interface. So essentially, you can do the processing at the edge, and the decisions could be sent over these interfaces intelligently, depending upon the application. So this sensor can actually provide a point cloud information and has a dedicated hardware accelerator integrated. On the right-hand side, you see our XWR6843, which is our superset device. It is similar to 6443, but it comes with a DSP integrated as well, so you can implement your complex signal processing algorithms on this device as well. We offer this device both in the flip chip BGA package as well as the antenna on package technology, and both of these devices are in production, both for industrial markets as well as automotive markets. In automotive market, we make it 125 junction temperature capable as well, and ASIL-B capable. On the bottom side, you can see the corresponding 77 gigahertz family of devices. And the three main things which I would like to highlight here are, if you are designing a sensor, irrespective of the frequency regulation restrictions on a region, whether it could be 77 or 66 gigahertz, we have a pin-to-pin compatible offering. So 6843 device, for example, is pin-to-pin compatible with 1843 below on 77 gigahertz, and it's also pin-to-pin compatible with 6443. So essentially, your design becomes much simpler now. Coming to software, it is one software investment. We provide a millimeter wave software SDK, which comes with common software APIs. And if you build your software application on one platform, it is very easy to build a different application or even port the same application to a different device in our family. And lastly, safety story is very important for a few of our customers. Our automotive sensors are ASIL-B capable for automotive applications, and for industrial applications, correspondingly, it will be SIL-2 capable. So overall, it is a common platform and common software investment and pin-to-pin compatible software hardware platform. So Texas Instruments not only provides silicon, but we also provide a lot of other things, such as software tools, which could be used for development purpose, evaluation kits, which you can readily buy on our website and evaluate any of these applications. We have a lot of ecosystem partners who have capability in design of this sensor, both production grade, antenna design, software algorithms for a multiple variety of applications. We also have dedicated training sessions, both in person and online. And we have a very excellent support system, or what we call as engineer-to-engineer platform, online platform where a person can post the question online and can expect an answer within 24 hours with our engineers worldwide. And this is true for both automotive as well as industrial applications. Just want to introduce what is our offering in terms of software. So on top of our radar portfolio, we have a scalable software SDK. And not only that, we also offer MCAL drivers, which is very essential for integration of AUTOSAR in case of automotive applications. We also provide safety software in terms of low-level drivers and exhaustive list of documentation and user guides, which our customers can use to certify their sensors as automotive safety grade or industrial SIL-2 grade. And in addition to that, we also provide a variety of application reference examples. It could be on the industrial space applications like traffic monitoring, robotics, people counting and tracking for building automation use cases, or on the automotive side, it could be vital sign detection of the driver, interior sensing, including child presence detection, short-range radar, mid-range radar. So our whole onus here is really to make this experience for our customers really easy to where they can readily find all these examples, buy the evaluation kit, and see for themselves firsthand how these applications work. So I'm sure this will be a very rewarding experience for you as you go through evaluating our chipsets. Now let's get into some of these specific application use cases. First one I'll get into is the occupancy detection in building automation use case. The goal here really is to detect and localize the people, their presence or absence, and also find out their exact location. And radar is very good at doing this because it can detect very high sensitive fine motions, and also compared to other existing technologies, it is highly accurate. In other words, the false detection could be overcome. And all of this without invading into the privacy of the users. In the three pictures, you can see the different use cases. And the first picture, you can see how depending upon how it locates a person, it can redirect the AC towards the person, thereby increasing the efficiency of the system. And in the middle picture, you can really see in the meeting rooms or in offices, the radar sensor can be used to detect where a person is, and based on that, control the lighting and even AC, for example. On the right-hand side, you can see the traditional ultrasonic sensor, which today is used to detect one car in one parking space. It could be replaced with one radar sensor, which could be used to detect multiple cars. So there is also this additional cost benefit for our end customers, along with accuracy. The second use case is the mobile robot sensing. Here, the sensors are really needed to detect a human presence or even obstacle, and mainly help them in case of AGVs or automated guided vehicles to navigate from point A to point B without any obstruction. The same is true even for autonomous mobile robots, where the robots could be made independent and with the help of sensors navigate even in a mainstream road conditions. And why millimeter wave or even 60 gigahertz radar sensor shines here is because radar can detect occupants and even obstacles in 3D space. And one major use case for this AGV and AMRs is cliff detection, which was traditionally done with the help of multiple sensors and even LiDAR, for example. Now with radar, you can not only detect objects, but you can also detect cliffs, because we can detect elevation. And because of this, you get not only accuracy, but also cost benefit in solving these problems. And not to mention, radar is robust and can work in challenging environmental conditions, giving that additional benefit. And the last application in industrial, which I will cover today, is the safety guards using TI radar. Traditionally, on the left picture, if you can see, these are the robotic arm movers, which is typically fenced in order to create a safety net. And with the Industry 4.0, our goal is to increase human-robot collaboration, thereby increasing the efficiency and the productivity of the system. And with the installation of radar sensor, we can detect where exactly a person is coming, with what velocity is approaching, and thereby slow down, for example, or completely go to a stop. So here, thereby increasing the efficiency of operation of the system. And for all these applications, now how do you get started to evaluate these applications? So at TI, we are really making it simple by following a three-step process. The first step, what we call as for each of these applications, discovery phase, where we make it available to you a lot of white papers, technology articles to explain you how the technology works, what it is capable of doing. Once you identify that, you go to the evaluation phase, where we offer a lot of evaluation kits for different scenarios, 60 gigahertz as well as 77 gigahertz, including reference software. So our goal is to make it plug and play, so you can buy the EVM software and check out for yourself the performance. And once you're convinced that this is the technology you want to go ahead with, you can design with our silicon. And we also provide a lot of documentation in order to enable that, including data sheets, design guides, and we also have a lot of ecosystem partners who can offer you help in any of these three steps. Now I'm getting into the automotive applications. In-cabin sensing, as I said, is gaining a lot of traction, especially with Euro NCAP requirements. 60 gigahertz sensor is leading the market. Conventionally, if you see, ultrasonic was tried in the past, but it is not 100% foolproof, and camera has its own drawbacks as well. And with radar technology, we can detect even a newborn baby covered with the cloth and seated in a child seat, rearward facing. Even under these stringent conditions, radar will be able to precisely detect as well as localize the presence of the baby. And there are a lot of options for placing the radar sensor within the car. It could be on the roof mount or the front mount. And because TI radar sensors are extremely small, it gives a huge benefit to our customers. And this is within TI. We did a lot of testing with the sensor on the roof mount as well as on the side. In this example, we are testing a baby doll, which actually simulates the breathing of a real baby. And we could see the baby placed on the bench of the seat, in the footwell, or in the child seat. And using our evaluation kit shown in the picture, we could really detect the baby really well. Using our 60 GHz 6843 device, which has been recently released to the market on the production device, you can use it in a multimodal fashion. What I mean by that is the sensor could be used not only to detect the occupants inside the car. The right side picture is detecting the 4 occupants across 2 rows. You could programmatically change the configuration such that it can now behave as an intruder detection sensor. The same sensor on the left-hand side picture, you can see that. And again, as I mentioned earlier, we follow this 3-step process to make it easier for the customers to evaluate our sensors. In the discovery phase, we have some technical articles, TI design documents, which you could use as a reference, and then evaluate our sensors, the 6843 ISK EVM, which is shown on the right, which also comes with reference software on our TI Resource Explorer. And then once you are comfortable with evaluation, you could design your board with the reference schematics and layouts we provide, and the silicon, which is all of it is available on TI.com. With that, I think we can open the floor for question and answers if you have.
Excellent. A few of you have already submitted questions, so we're going to jump right in. If you'd like to submit a question, type your question into the question window on the side of your screen and hit the submit button. While we're answering your questions, please complete the feedback form, which is located at the bottom of your screen. So where can we find more information on the algorithms that are used in your example software?
All of our software and algorithms are hosted on our TI.com website. If you go to ti.com/millimeter-wave, we have both automotive as well as industrial section. And there is an applications tab, and depending upon your application of interest, you can find the right link to both evaluation as well as software link. In addition to that, our millimeter wave SDK also includes a reference software along with the library of a lot of algorithms which are used for these applications. And in this slide, we provide a lot of links, and depending upon your application of interest, you could click and it will take you to the right location of software.
All right. For mobile robot sensing applications, should you be using 60 gigahertz or 77 gigahertz?
It really depends upon the region. From our understanding, it would be 77 gigahertz if it is US or Japan markets, but we are seeing that rest of the world is moving towards 60 gigahertz. So it depends upon the region, and that is the reason we offer a scalable portfolio, pin-to-pin compatible hardware and software.
Can the systems identify moving objects?
Absolutely. If you're thinking, I don't know what you're thinking about, but in the automotive space, just to quote an example, our radar sensors, when we tested by placing the sensor behind the bumper, we could detect cars, even motorcycles, moving at, for example, 60 to 70 meter at high speeds. So that's one example. And in the industrial application, for example, it could be safety net, which I spoke about earlier in the automated robotics. There, it could also detect humans which are approaching or moving away from the sensor. and it can do this pretty accurately at 4 centimeter range resolution.
Does TI provide a profile library or something to address different use cases?
Yes, TI has a host of tools. One of the tool is called as a millimeter wave studio. You can actually connect that tool from the PC directly to our evaluation kits, and you can control the different options through a GUI and choose different profile configurations. So that is one option. And the second tool is called as millimeter wave sensing estimator. In that, you can determine what your use case is. For example, if you want to detect a person at 10 meters, if you input those parameters, the tool will throw the right configuration, which you can load into the sensor and start evaluating right away. So there are 2 to 3 tools available, and also a lot of documentation for you to help in this regard.
Would it be possible to use radar on a forklift application to track accidents due to the moving forklift and people?
Absolutely. So this is one of the applications which I mentioned earlier. We have seen some of the customers use radar. The main reason they use it is because of its ability to accurately provide the velocity information as well as the distance information of the approaching humans. And based on this, the forklifts can determine, take the appropriate action.
Okay. This person would like to know about the range of the radar sensors. Would it be suitable, and what would you need for examining and controlling a traffic light?
Sure. So it depends upon the application. For traffic monitoring applications, we have seen it could be, depending upon the region, the distance of detection could be 60 meters to more than 100 meters or maybe 120 meters. And with the TI radar, our devices are highly programmable. And based on the chirp configuration and profile you load, you can control this range of detection. And part of it is also dependent on the antenna. And we provide some of the reference examples which you can find on our ti.com already, which actually shows this long range detections already.
Okay. Is 60 gigahertz radar being used in automotive applications only for in-cabin sensing? And why exactly was 60 gigahertz chosen?
Okay, so predominantly we are seeing 60 gigahertz is being used mainly for in-cabin sensing. The other applications we are seeing in some part of the world for kick sensors, 60 gigahertz are used. But for the most part, interior sensing uses 60 gigahertz. The reason is FCC last year brought out a mandate which prohibited 77 gigahertz from being used for these applications. And it might be mostly because of interference reasons.
Okay, why would one choose a radar system over a vision system for certain applications?
It really depends on the applications. Just to give 2 examples for interior cabin sensing, camera doesn't work 100% of the time. There are concerns around privacy. And also imagine a camera sensor in the front. It cannot really detect a baby which is placed in a rearward facing position or the baby which has fallen into a footwell. Radar in any of these conditions can detect the baby really well. To quote a second example for elderly monitoring, which is an industrial application, there is a concern on the privacy as well, and also the range of detection. Radar is very useful to avoid these privacy concerns, and also the amount of complexity involved is drastically less on a radar sensor. And also from the cost point of view, radar sensor is highly attractive, and it can do multiple functions as well.
Okay. Is the 60 millimeter wave in the ISM band?
I think it depends on the region. From what I understand, 57 to 64 gigahertz band in Europe is in the ISM band. In the US, it might not be. It depends. I can take that action to get back to the user later on.
Okay. Is the 60 gigahertz transmitter part of the sensor? And if so, what is the launched power level?
So in our sensors, the transmitter as well as the receiver both are integrated into the sensor itself. So it's an integrated sensor. And the output transmitter power is around typical 10 to 12 dBm output power per TX channel. And depending upon the application, you could either reduce it or increase it programmatically on our sensors. But the maximum is about 12 dBm. And the data sheet provides that information as well.
For industrial sensors, can it detect stationary objects?
Absolutely, yes. This, for example, in one of our examples, we have shown automated gates and doors. If you install the sensor, typically it would open for, even if a bird is coming in, right? And if there is a trolley, for example, coming in, the radar sensor can accurately detect that as well. And in case of parking up, sorry, I was going to finish up.
No,
even in the parking, in the parking application on the automotive side, for example, it could also detect a lot of static objects too.
Okay. Is it possible to fine-tune the TI software to tailor it for specific use cases?
Yes, it is possible. All of our millimeter wave software SDK is on TI.com. Anybody can download it, and it is highly programmable also. And anybody can choose it to fine tune. There is a lot of documentation on how to do that, application note and user guide. And we have seen a lot of people do that very successfully.
Excellent. Well, I'm afraid we've run out of time. If you asked a question that we were not able to get to, we will be in contact with you soon to answer all of your questions. This concludes today's presentation of electronic design. I'd like to thank Texas Instruments for sponsoring today's event, and of course to all of you for joining us. Have a great rest of the day.